So this one says find the Maclaurin series of the given function. So we got f of x equals sine of x over x. Now what we're going to do is we're going to find this one. But I'm not going to pick the f of x that's there. I'm going to pick the f of x that equals the sine of x. And we've done this one already, but I'm just going to go through all of the derivatives. I'll do the first couple so you can see what we end up with. And the next one is going to be f double prime of x, and that's going to equal negative sine of x. Now I'm just going to run through a few more so you can get an idea of what these look like. Now that I listed a few here, and we need quite a few to do these sine of x's because you're going to see that every other one is going to be 0 when we actually plug in 0 now. And now that's what I'm going to do for each of them. I'm going to do f of 0, and that equals 0 for the first one. And then f prime of 0, oops, and that's going to equal 1. And I'm just going to run through the rest of these and show you the values. So really the non-zeros here, after I write them all in there, we see that the pattern is going to be the prime, the triple prime, the fifth derivative, and it's going to be every odd power. And we're going to have a 1, negative 1, positive 1. So we're going to have this alternating sign going on as well. So now we're just kind of going back to the Taylor series, and that's the equaling all of this here. So again, we need the primes here, and that's what we're going to put here. And remember, we're skipping every other one. So the first one's 0, and that means the second one is where that's n equals 1 stays, and the squared is 0, and the third stays, x cubed stays, x to the fifth stays. So every odd is staying. So that's going to give us the first one being f prime, so that's going to be a positive 1. So that's going to be the 1 factorial over x to the first, okay? And then remember, we have those alternating signs too, so that's a negative is going to be my next. So negative 1 over 3 factorial, because remember, we're skipping every other one. Every other one is going to 0 out, and that's what we see down there. So then that's going to be x cubed, and then plus 1/5 factorial x to the fifth. So the next one, if we did one, would be x to the 7th. So that would be 1 over 7 factorial x to the 7th, and then so on. So the nth one, let's see if we can do the nth one now. Okay, so the nth one is going to be plus, and we're going to have 1 over, and remember, we're doing odds here. And I wanted to start with the 1 there. So is that going to be 2n plus 1? If I'm starting at 0, right, that's going to give me the 1 factorial. Because the odd numbers is 2n plus 1, or I can use 2n minus 1, or any of those in that variation. Okay, so now we're thinking of the x here in the same way. So it is going to be the same formula because I'm getting the same numbers for both of those. So that's going to be our pattern that we see. Hopefully that was okay for you. If not, get a hold of me. And then this is plus dot, dot, dot. Okay, so that's our series that we get for the sine of x. So if you didn't get that before, there it is again. So now we're going from n equals 0 to infinity. And that's how I set this up. And again, I definitely want to test it once I find one. So I can call this x to the 2n plus 1 over 2n plus 1 factorial. Oh, I forgot something here. What did I forget, guys? Did you guys catch it? I forgot my signs. My signs should have been alternating. So since this was a positive, this was a negative, this should be positive, and this is where I went awry here. So that one there should be a negative. So I missed my sign there, which means my formula is going to be off a little bit because I didn't account for that alternating sign. So this is really going to be a negative 1 there. And now when I do my first one with n equals 0, I'm positive. So that's just going to be an n. Because when I plug in a 0 there, negative 1 to the 0 is going to be a positive, and I've got a positive 1 for the first one. Okay, and then when I plug in a 1 there, that's going to give me the negative there. Okay, so that worked out. I apologize for not putting that in there. That's crucial. We have to have that. So now I'm going to have to fix this top a little bit. Okay, so on the top then, I'm going to have to put that negative 1 to the n in there. And then that's going to be x to the 2n plus 1. So there's our actual series for sine of x. Now the cool thing about this is, now that we have that, look what we're doing here. If we're looking at the sine of x over x, we're in essence dividing all of this by an x. So all of this, we're going to divide by x. And notice what happens here. This is going to cancel with one of those. Then when I do the x here for the second one, it's going to take one of those away, and one of those away, and one of those away. So when I divide this whole thing by x, okay, I'm going to do the same thing with this one too. So I'm going to divide this by x, and it's going to take one of them away. So I'm going to actually get 2n there for that piece there. All right, so then it's like I'm taking this whole thing and saying, hey, dividing it by an x. So then our final series then is going to be so there's our answer.